Over the last 60 years, we've visited a lot of places in the solar system. The sun, the moon, all 8 planets, some comets, even Pluto. Every time it seems like we've been everywhere worth going, some new and amazing object shows up. And these days, many of those objects are asteroids. Astronomers have been discovering asteroids since the early 1800s, but modern technology has turned them into the hottest new frontier of solar system exploration. So let's look at 3 exciting discoveries that marked firsts in asteroid research and gave us great reasons to keep exploring the asteroid world. First up is asteroid 24 Themis, discovered in 1853 by astronomer Annibale de Gasparis. It's the parent body of one of the largest families of asteroids, made up of thousands of objects that all seem to have been knocked off Themis by ancient collisions. So it's got that going for it. But more recent telescope observations made in the mid-2000s gave astronomers even more reason to be interested in this rock. Their observations suggested that asteroids like Themis could be responsible for something pretty important: Earth's water. For a long time, planetary scientists had imagined a clear distinction between asteroids and comets. They thought asteroids were bone dry, and only comets, which orbit farther from the sun, were covered with ice and snow, and therefore could have hit Earth and left behind water molecules. The only problem was they didn't see that clean division in their observations. Some meteorites, which mostly come from asteroids, show evidence of having formed in the presence of water, and a few objects in the Themis family also had features more typical of comets than asteroids. So that made it natural to check out the parent body in more detail. When 2 separate teams used NASA's Infrared Telescope facility in Hawaii to study Themis in the mid-2000s, they found something pretty surprising. A thin layer of frost seemed to be covering its surface, and embedded in that frost were carbon-based molecules, the building blocks of life here on Earth. Themis seems to orbit just far enough from the sun to keep it all stable. The fact that it's possible for an asteroid to hold onto ice is pretty fascinating, because planets like ours probably formed from asteroids like Themis. And as all that rock clumped together to form planets, the water and organic molecules must have come along for the ride. Themis isn't the only asteroid where we've discovered something hiding in plain sight. And for 87 Sylvia, that something was pretty big. Not just 1, but 2 of its very own moons. Asteroids with tiny little moons! It sounds pretty cute. Astronomers first spotted Sylvia orbiting in the main asteroid belt way back in 1866, but it took until the 21st century for anyone to spot its companions. Scientists noticed its first moon in 2001 and its second 4 years later. We'd found lots of double asteroids by then, but no one had found a triple system. Now we know they exist, and they can be pretty useful. By tracking the paths of the smaller moons, astronomers were able to pin down details about Sylvia's mass and density. Those gave them clues to its composition, which can be tricky to figure out in an asteroid. But of course, the first order of business was to give the moons cool names. Sylvia was named after Rhea Silvia, the woman ancient Romans believed gave birth to Rome's founders. So, of course, the moons are named for her sons, Romulus and Remus. But the names are more than just some good, clean, historical fun. The evidence suggests that the moons might literally be from Sylvia itself, knocked off during an ancient collision. In fact, researchers think there could be even more moons, because Sylvia is what astronomers call a rubble pile. Basically, instead of being one big, solid object, it's more like a collection of rocks held together by gravity. That means it would be especially easy to knock off bits and pieces during a collision. Research suggests that up to 6% of asteroids might have at least one companion, but Sylvia was the first one spotted with multiple. Not bad for a pile of rocks. Our final nifty asteroid is 163693 Atera, named for the Pawnee goddess of Earth. And when it was discovered in 2003, Atera was the first known asteroid that was always orbiting closer to the sun than Earth. Since then, astronomers have found around 20 more, but these objects remain really tough to study. For one, Atera is small, with a diameter around 5 kilometers. But more importantly, it can be tricky to study objects closer to the sun than us. Because you know what else is in that direction? The sun, which is definitely not an astronomer's friend. But these objects are definitely worth studying, because it's sort of surprising that asteroids like Atera can stick around at all. Atera's orbit is really elongated, Sometimes it nearly reaches Earth, while at other points it can be just half as far from the Sun. That means that while it never crosses Earth's orbit, it does pass through the part of space occupied by Venus. Usually, crossing paths with a planet is bad news. Over time, it's pretty likely that its enormous gravity will fling you around. So how come Atera and its family are still here? One hint comes from their inclination. Atera's orbit isn't just elongated, it's also tilted more than 25 degrees relative to the plane of the solar system. Objects that are both tilted and elongated can experience what's called the Kozai-Lidov resonance. Over time, they can basically trade elongation and tilt back and forth in a way that helps stabilize their orbits. Most of the time, we see this effect with planets orbiting other stars, so it's pretty exciting to see it up close. So it's no wonder that researchers are proposing that Atera and its friends would be a good target for a future spacecraft to visit. Really, any of these unusual asteroids would be great places to check out. And thanks to these 3 discoveries, we have a much better idea of what to look for. Thanks for watching this episode of SciShow Space. And if you like learning about asteroids, you might like our video about the asteroid belt, where most asteroids come from. Chances are it's pretty different from what you might have imagined.